record on this computer. Okay, cool. So I'll share my screen. And unless anyone has anything else they want to talk about, I'll do the normal thing and go through some part of the code base, and we'll just take it from there. So if you have not been to one of these before, welcome. So the way that it usually goes is, like I said, I choose a part of the code base if no one else has an idea of what they want to look at. And I'll just go through super slowly sort of each little section of that part of the code base. And if people have questions, if you have a question or comment or anything like that, you can feel free to interrupt me and put the question in the chat for Zoom. And we'll just go like that. And if there's a question that takes us in a different direction, that's totally cool. And we'll just go with the flow. So here we go. Let me share. Can anybody not see this this screen? It should be a GitHub issue in Firefox on the screen right now. Can you put in chat or shout if you can't see? Okay. Looks like everyone can see. All right. So the first thing I want to mention, issue number 1323. This one is just personally for me. If you do use Athens in production at your work or on your team or sort of in any way that you rely on it, I would love to hear about it. Actually, all of the maintainers would love to hear about it, just because it helps us know like what to look out for, if there are use cases that we're not hitting, if there are issues that we're not fixing that really need to be fixed, all that kind of stuff. It's sort of like knowing our users. So if you can, please comment on this issue if you're using it at your work or in production in some way. And I personally read all of these, obviously, and if you comment on here and you want to talk, really it's just a matter of write down who you are, what you're working on, how you're using Athens in here, and just come say hi in the Athens channel and we'll talk. So that's my my commercial for today. So let's go into the code. So in the past, we have gone through and we've talked about the config system, and that would live sort of starting here. This is how like configuration values get from the configuration file and environment variables and then get into Athens, get parsed, and then how they flow through all pretty much the entire code base. We also talked about storage drivers. Those were in the PKG directory. We talked about like kind of generally what is a storage driver, and we also dove in a little bit to the MongoDB storage driver. And then we also talked about handlers. Those were the actual HTTP routes, and that all kind of started here under add proxy routes. So that is like kind of the very, very highest level of what Athens does. Basically, it's a configurable HTTP server that is backed by some storage. That's pretty generic. You know, you could say that about pretty much any web app on the planet. Everything connects to a database. So today I thought we would take kind of a different turn and we would talk about how Athens gets deployed. Specifically how that athens.azurefd.net Athens gets deployed. So for those who don't know, this is what I'm talking about. So there is a public experimental Athens that lives on the internet. It's deployed at this like kind of placeholder URL. And really it's not meant for production use, although I've heard of some folks using it for production, and I've also sort of said like, hey, it's not really supported. But it exists because it's a nice way to let people check out Athens and play around with Athens. without having to install Athens at all. So I wanted to go in sort of behind the scenes and show how this thing is deployed, just so it might make sense to other folks if you're interested in deploying Athens, either in this way or maybe in a similar way. So starting with the docs page under docs.gomods.io, we have a whole section on installing Athens. And there are two ways that I have done it for this public instance. I've installed it with Kubernetes, and I'm actually working on another install. So I've installed it twice on Kubernetes for this public instance, and I'm working on the third one. So basically, I followed this exact instructions and got it up and running. And I've also done this, which is an Azure specific one, using this Azure Container Instances system. And that is what is currently running and serving up the athens.azurefd.net service. So I'm going to actually dive into how I did this. This will be pretty quick. And then I'm going to dive into the Kubernetes stuff that I did in the past. And hopefully some of this will help. And again, chime in if there's something that you want to dive into deeper, or you don't understand, or questions or comments on, or anything like that. So I have this little repository called Athens-Azure. And all this stuff is hosted on Azure because I work there, and I get it for kind of free, pretty much free. It doesn't come out of my pocket, which is nice because it's a public service and people are using it. So basically this whole thing boils down to this ACI.sh script. So it's a pretty fairly simple shell script. It has deployed to 4 different regions, sort of around the world-ish, leaving out some of the major continents, but it gets pretty close to all of the major continents. And basically it just runs this big, huge command called az container create. So what's going on here is this is basically like Docker run, but it's Docker run that gets a public IP and a public DNS name. So I actually have this whole repository checked out, and I'm going to go open up that specific script in VS Code. So if we make this a little bigger, not that, if we make this a little bigger like this, and I head over to this ACI.sh file, this is what was in GitHub. We're basically just doing like a Docker run, and we're specifying an image, and then we do a bunch of environment variables, and this is the Athens configuration. So the one in production is using MongoDB as the backend, and I'm setting it to use 5 backend workers to do the go mod download command. So for those who don't know, Athens uses the Go tool itself on the back end if it needs to go and download some code from an upstream, from GitHub or GitLab or wherever. And there's this variable here, this environment variable, which tells Athens how many of those Go mod downloads should be running concurrently at any single point in time. And this is actually really useful to understand if you're deploying Athens, because let's say you're deploying Athens to a tiny little VM or a Docker container that has really limited resources, especially limited memory and network bandwidth. If you have, let's say, 100 Go mod download commands running at once, that can get really problematic because you might run out of memory, or you might get network hiccups because you have limited bandwidth. And that can cause Athens to spit out 500 HTTP 500 errors, and that can fail your build. So the reason that I have set this low is because I am assuming that someone can come in and do a Go build, and that Go build can require dependencies that the public Athens doesn't have stored already. And if that's the case, then every one of those dependencies is going to require a call to go mod download instead of just grabbing something from storage. So I don't want this Athens instance to get overwhelmed with go mod download requests. And what this is saying is that there should only be 5 go mod download requests at once. And every other request that comes in that needs to do a go mod download needs to wait. So what that means in practice is that if you do a go get or a go build, and the dependencies, the modules you depend on aren't in this public Athens, the build is just going to take a little bit longer for you that time. But of course, since Athens stores this stuff after it downloads it the first time, the second and third and fourth and so on, all of those builds are going to be fine because they're not going to require a go mod download call. So that's the most important part of this deployment. And any other deployment that you do, it's pretty important that you understand this and that you also understand another command, another configuration directive, and that is called Athens protocol workers. So that is right below the Athens go get workers. Okay, so go get workers is like the back end code fetching, and protocol workers is the front end. So it's literally the number of requests that you can serve, that Athens can serve over the download protocol. So the number of HTTP requests that can come in that Athens will be willing to serve at a time, essentially. So if you are running a server that you expect to always be getting new modules that Athens has never seen, you want to control go get workers and make it lower, on the lower side. Unless you have a VM or you're running Athens on some system that has a ton of network bandwidth and you're giving it a ton of memory. But if you restrict go get workers, you'll be restricting the throughput of Athens, so the number of requests it can serve at a time and over a window of time, because Athens will always not see the stuff in storage and have to go out and do a go mod download to get the new module. But if you are running an Athens where you expect dependencies to just be there in storage almost all the time, and that would be common in the case of something like an internal instance that's serving up dependencies for your private code base. In that case, Athens is probably going to rarely have to go out and do a go mod download. And instead, it will almost always have stuff stored in storage, in its database or file system or wherever you choose to store code or to store modules. And in that case, setting protocol workers to a higher number would be more valuable, because essentially what Athens is going to be doing is it's going to be getting a request for a module, and it's just going to stream the data for that module, the .mod file and the metadata and the actual source code in the zip file. It's going to be streaming that stuff straight from storage back out to you, the person running go build or go get. And that's not going to involve a go mod download or any command to the go, or any call to the go command at all. So if you have an Athens that is sort of, the cache is warmed, it makes more sense to have a high number of protocol workers, just because it's going to be talking to the database and returning data, and that's it. So going back to this command, I'm telling Azure I want a public IP address, and I'm telling it I also want a DNS name, and then I'm running it on port 3000, which is the default Athens port. Okay. So this is sort of way one that I've done it. And without getting too deep into the Azure specific stuff, I can save that for another time if folks are interested. But basically all of these 4 Docker run containers, they're literally doing Docker run inside of a cloud. And then I put a caching proxy in front of these Athens. So there's one domain name, that's the athens.azurefd.net domain name, that goes to the caching proxy. And then the caching proxy does load balancing across all 4 of these different regions. But Athens, the Athens that is running at this domain name is actually fairly performant because all but 2 of the download protocol endpoints can be cached forever. And the promise of Athens is that the code that it has stored already is never going to change or disappear. So that means that we can cache in a content delivery network, or CDN, we can cache the .mod file and the .info metadata and the .zip file for any module that Athens ever serves up. We can cache it globally forever. We never have to worry about deleting it or changing it. So if you have done a Go build against this athens.azurefd.net server, if you've ever done a Go build against that server and it was slow, the second time you do it, it will be extremely fast because all of the code that you requested has already been stored both in Athens storage and then been cached in this global cache, this CDN. So the 2 exceptions, though, are the /list and the latest endpoints. So the /list endpoint gives back all of the possible versions of a given module that you pass. And then the latest endpoint gives back just the latest version of the module that you passed. And those things can't be cached because Athens has no idea when there will be a new version, and of course, when there will be a new latest version as well. So the list of versions might grow or shrink, and the latest version always could change. So we never cache that, and Athens is built in such a way that it never passes back HTTP headers that indicate that the thing should be cached. Okay, so I'm going to pause there. This is the sort of more Azure specific way. This is the way that it works on the back end. I'm going to pause there. Let me know, folks, if you want me to go deeper into this, or you're good and you want to move on to the Kubernetes part, or if you want to talk about some other part of deploying Athens. Let me get some thumbs ups, thumbs down. Do people want me to keep going on this direction or go to Kubernetes? Anybody? Otherwise, I'm going to start telling bad puns. So you got to say something. A chat message. Cool. All right. Yeah, let's check out the Kubernetes stuff. So, Chris, you're here for the bad puns. Okay, well, you're in the minority, so we're going to just talk about Kubernetes stuff, and I'll tell you bad puns later. How's that?
That's fine, mate.
Okay. All right, so all the Kubernetes stuff is centered around Helm. So, quick intro to Helm. If you have questions about Helm, just interrupt me and we'll go a little bit deeper. So Helm claims to be sort of the package manager for Kubernetes. And what this actually translates to in Kubernetes is you deploy stuff to Kubernetes by sending up some YAML, some markup language called YAML to a server. That server is called the Kubernetes API server. And generally speaking, any real internet service is going to have multiple different of those YAML files because the YAML files really just indicate one little piece. So each YAML file is called a manifest, and Kubernetes is made up of all these different types of things. There's pods, which are the actual running Docker containers. There's stuff to deal with networking and routing and storage and all different kinds of stuff. So a real application, including Athens, isn't just a pod. It is also all the other stuff surrounding a pod, which is, again, the running container. And it's all the stuff that surrounds the pod to make it work and have a public IP address on the internet and be connected to MongoDB or whatever your other storage system that you're using is. So we're using Helm to do that. And Helm is basically a bundle or a package, which is where the name package manager comes from, of course, It's just a bundle of all of those manifests ground up into one sort of deployable piece. And then on top of that, it has the ability to parameterize those manifests. So if you want to change the MongoDB connection string, you can do that by kind of just putting a little parameter in. And I'll show you what that looks like. And then also it keeps track, it sort of has like a release log. So it's easier to roll back, roll forward, to kind of audit the history of deployments in your Kubernetes cluster. And the list goes on, sort of so on and so forth. So tons and tons you can read about Helm here on helm.sh. This is the site. The docs are really good. This is a really mature project. I actually used to work on this, so I like it. I have an affinity to it. But it's a pretty mature project as well. It's part of the Kubernetes ecosystem, and it's officially recognized and all that stuff. So jumping from the general Helm stuff into how does Helm apply to Athens, let's go in and see what the Athens Helm chart looks like. So remember, a chart is basically a package. So chart is just a synonym basically for package. So heading over to charts and then Athens proxy underneath the charts directory, a chart has these basic 4 files: chart.yaml, owners, readme, and values.yaml. And then it has this directory called templates. So really, the only 2 files that we need to pay attention to are chart.yaml and values.yaml. These other 2 are important, but they're for humans to read. Obviously, humans are important. Humans need to read stuff. But for the purposes of today, we have 35 minutes. I'm not going to go too deep into these 2 files, except to say that README is important because it's just like a GitHub README. So it documents how to use this whole chart, which is really nice to have. The other piece, this is the second most important file. This is basically a manifest, like you would see a manifest in like a Debian package or something like that. This is just metadata about the package. This is used in a variety of different systems to show like things like the icon that represents Athens, links to the homepage, the maintainers. This list needs to be updated, by the way, because there's a lot more. The chart version, all kinds of other things. And this actually is an incomplete list of all the things that can go inside of a Helm chart.yaml file. Then there are the parameters. So this is the most important file pretty much in the whole Helm chart. So there's a ton of stuff in here, and these are all of the things that you can change for your deployment. So if you think of like a Helm chart as a function, these are all parameters that you can pass to that function. So like check out here, for example. This is the tag of the Docker image, the Athens Docker image. The most recent one, the most latest release of Athens is v0.5.0. We just haven't updated it here yet. So if you haven't done a PR yet and you're looking for your first contribution, this would be a good one to do. It's a one-liner, but you'll actually find that it's very interesting. And you'll find some things along the way that you also need to change, and it would be cool. So if you're looking for a place to get involved with Athens, this is a good one, and feel free to ping me in the Athens channel. I can get you started. So that was a little shameless plug for contributing to Athens. But going on to like other things here, you can control like what port do you want Athens to run on. So obviously port 80 is good, but you can have Athens run on port 1,000,000 or whatever. I guess the highest would be 55,000 or so. I might have that wrong even. But then we keep going down. Like this part is important. This is how you set up storage. So by default, storage is set to local disk, but this running inside of a Docker container, local disk can go away because Docker doesn't have persistent disks by default. but then you can do cool stuff. Like you can turn on persistent disks, or you can change it to use S3 or MongoDB. And then going on, there's other stuff. You can go down and enable private Git repositories, point Athens to not a VCS, but instead point it upstream to another module server. The list goes on and on and on. So this is how like you can conveniently change basically the configuration of Athens. But then the rubber kind of really hits the road, if you will, in here, because these are all the YAML files that Helm actually will send up to Kubernetes. So going in, the most important one, the one that at least I look at the most, is this deployment.yaml. So first thing is check out all these little mustache things here. They're everywhere. You go down, they just keep going and going and going. Those are all parameters. So if you're familiar with like mustache templates, or you're familiar with Go and you've used the Go templating system that's built into the standard library, that's basically what these are. These are actually powered by the Go template language. So if you're familiar with that, you'll be familiar with this. If you're familiar with mustache templates, you'll be pretty fairly familiar with these too. So this stuff is kind of boilerplate. So I'll just explain one of them. This thing is calling another Go template to get, in this case, it's to get the full name of the application. This is a fairly common pattern. It basically just gives a unique name to this deployment so that no other deployment in Kubernetes conflicts with that. And then going down, we have like this thing called a spec, and then the spec has a template, and then really confusingly, the template has a spec again. So it's, what is it? It's spec.template.spec. And now we go into like the actual containers. So this is what containers are actually running when you start up an Athens chart in Kubernetes. So there are two pieces. There's init containers and containers. So init containers run before any of the containers that are under line 45 run. I'm not really going to go too much into these. Basically, though, you can run any container you want, and it will run to completion before Kubernetes starts up any of these containers down here that are below line 45. So for this one, we're copying over SSH keys inside of the container. And that is useful for private GitHub repositories or GitLab or anything else like that. And then down here, this is where we go into actually launching the Athens server. So again, we name the container that, fully globally unique name. And then by far the most important piece is this line. This is the image. So if we go back to that values.yaml file, we're going to look for image.registry, image.repository, and image.tag. So checking out here, there's the image.registry, repository, and tag. Okay. So by default, if you run Helm install, it's going to install version 0.4.0. We'll see in a little bit how to override that from the command line if you want, and not have to just change this in the file. So this is going to say, Kubernetes, please deploy Athens version 0.4.0. Going down a little bit, Kubernetes can do these little HTTP probes to make sure that Athens is still healthy and running. And if it's not, then it'll try to restart Athens, hoping that it will be healthy. And then down here, under env, this whole section is the second most important part of the entire Helm chart. And that is because these are all the configuration variables. So this is literally, you can map these values back to what you see on the config page over here. So like, for example, take this page. That's a bad one. Take this page. So for example, every one of these environment variables that you see here. So let's take Athens disk storage route or disk storage route, AWS secret key, and on and on and on, all these environment variables. They can all be set inside of this env section. So this is really messy, but it's essentially, it's a array, a YAML array of key value pairs. So we talked about go get workers before when I showed you the other deployment script, the ACI, the Docker run in the cloud thing. And this is how you set it in Kubernetes. So what we're saying here is if you have set the go get workers value in Athens, and that is down here. So by default, it's set to 3 in Athens. So if you have set it anywhere in the values.yaml file, or you set it on the command line, then it's going to insert that value in as the value that you're going to send to the container running in Kubernetes. And otherwise, we're going to default it to 3. So there's kind of 3 layers here of configurability. So the first one is if you do nothing, then go get workers is going to be 3. Then the second layer is if you set it in here, you set it to whatever you want to set it to, then that's going to show up in here. But then there's a third layer. You can override even this on the command line. And if you do that, then that value will show up in here. And the same thing goes for everything below. So anytime you see dot values dot anything else, that is going to first check the command line if you pass something in on the command line. And second, it's going to check whatever is in the values.yaml file. So, I mean, this goes on and on and on and on and on. And it even has some, not just some if, but some more complex stuff. Like we have some auth in here. And then we check some, this is sort of a more complex if. We check to make sure, what is this again? This is for persistent storage. This is to deal with like the netrc file to do private repositories. I mean, this list goes on and on. I couldn't even tell you what all this stuff is at the moment. So this is all bundled up into one big 229 line YAML file to describe how a container needs to run on Kubernetes. Now that's crazy, of course, because you shouldn't need to memorize 229 lines of YAML just to run a container. But you don't have to with Helm because this is all written and checked in. And really, you only have to understand a few parameters in order to deploy the thing to Kubernetes. And in fact, I mean, we're only looking at one YAML file. There are however many YAML files in here. And we wrote fairly decent and short documentation on how to deploy stuff, how to deploy Athens to Kubernetes, because Helm kind of wraps all this stuff up into a command. So let's pause again. Let's take bearings. Do we have questions or comments on this file, on this file or any of the stuff around YAML that we talked about? Speak up or write in the chat if you do. Anybody? Okay. Let's continue then. So the second most important piece of the Athens Helm chart is the service.yaml. This is the thing that does the networking. So the pod in Kubernetes is controlled by this deployment.yaml. And deployment.yaml actually runs a specific number of pods. So this is the replicas. This tells Kubernetes always have X number of the Athens pod running at a time. But those pods can be anywhere. They can be at different IPs inside of the cluster, inside of the Kubernetes cluster. And that's kind of a mess to deal with. But a Kubernetes service that's under service.yaml, it kind of just abstracts it all away and gives you a single IP and a single port inside the cluster that you can just talk to that, and then internally Kubernetes will route to all those pods that are always moving around. And then even better actually is this thing can automatically give you a load balancer in whatever cloud that you deployed to. So you can literally do your Helm install on the command line, and if you wait a little bit for the cloud to provision a load balancer, you can actually get a public IP address too. And that's pretty cool, because then you get a one-liner and you get your thing on the internet, which I like. And that's actually how I did the very first deployment of that public Athens. And then I blew it up because I accidentally deleted the whole Kubernetes, but that'll be a story for another day. So this thing, again, like everything you see, dot values, they're here, they're everywhere. These are all coming from first checking the command line and then checking the values.yaml file. Okay. So there's plenty more. There's these things called ingresses, which are like how you route from the external internet into the cluster. So it's kind of hooking up a public internet request to a service. There are secrets. These secrets are for secret values, like you can imagine an SSH key would be a secret value. These things called PVCs, or persistent volume claims. These are for disk-based Athens storage, so that if an Athens crashes, all the modules will still be stored on volume in the cloud, like Amazon EBS, for example. And Kubernetes will then automatically make sure that that disk is attached to the new Athens that gets spun up and replaces the one that just crashed. So, you can spend hours looking through these. I don't know how many total lines it is, but I think it's probably over 1,000 lines of YAML. So you don't have to, and that's great. Instead, I would recommend that you go to installing Athens and then install Athens on Kubernetes. And this goes through the whole process of installing Athens on Kubernetes. So I think I have a Kubernetes cluster installed, and I think I have gone all the way through. I've gone up to, I think I finished this section. So I haven't done deploy Athens yet, but I'm pretty sure I got through all this. So let's do it live. Let's try to deploy an Athens to Kubernetes. And you guys can all laugh at me if and probably when things go wrong. But hopefully in the next 19 minutes, cross your fingers, we can have a running Athens on the public internet. And we'll do it basic. We'll do it with disk storage, so we don't have to set up any other, MongoDB here or anything like that. So it'll be a fairly basic one, but we can have something. So let's go and do, first, let's do this one, Helm repo add go mods. By the way, is anyone unable to see the terminal? Can you just shout if you can't see it? And I'll make the text a little bit bigger too, just in case. Okay, there we go. So we did that. I'm going to update the repo. So the repo in Helm is a collection of charts, a collection of packages. And then the packages are indexed, so you can search them and stuff like that. So the Athens project publishes one to this URL, basically the Azure version of S3. And then Helm knows how to download the charts from it and then search them as well. So when I do a repo update, it's downloading new charts, essentially. So there you go. It got an update, and I think I haven't updated since v0.3 on this machine. So now it got v0.4 and 0.4.1 and 0.5 and everything in between 3 and 5. Now, this is the moment of truth. I'm not exactly sure if this is going to work, so let's just copy and paste and pray. Pray to the demo gods. Waiting. Okay, well, something happened. So this is generally this is what it looks like when you do a Helm install. So first of all, this Helm install is saying take this Helm chart, and this is the Helm chart that we got from that from this URL. And that Helm chart is basically the same thing as I showed in VS Code before. And it's saying deploy it to this namespace in Kubernetes. So if you're not familiar with Kubernetes, Kubernetes is split up into any number of namespaces you want, and then you can do ACLs on the namespaces. So I can have an account that can only talk to this namespace, and you can have one that talks to that, and you can do a bunch of cool stuff with namespaces. So I'm saying I want to install my Athens in the Athens namespace. And then I'm calling this a release. So Helm has the concept of a release. So I am calling this the Athens release. And a release is essentially the same thing as a deployment with a specific number of configurations. So sorry, that was my phone. So I've done that. I have done my whole deploy thing. This is exactly what it looked like in the cluster right after Helm did the deploy. And now I can do a Helm list. Let me clear the screen here. I can do a Helm list, and I can see that that Athens has been deployed. So it's successfully been deployed. And you can check out app version is 0.4.0. That was because I didn't update on the command line to 0.5.0. And then I can do Helm status. Let me remind myself how to do Helm status. Yeah, so I can do Helm status Athens, I believe. Yeah, and that'll give me all the stuff that was deployed in the Athens. So the thing that I'm looking for is here. So in the service, you can see I would like to have an external IP, but I don't. And that is because I need a service, I need a different type of service called a load balancer service. So that's good to know. In order for me to get that load balancer service, and hence to get a external IP, what I need is to change a configuration variable in Helm. So let me go back into my Helm chart and check out what to change. So I'm not going to go into these templates. This is kind of the great thing about Helm, is I can just go into here and find that service section, and I can check out the type here. So type is cluster IP, but it says that I can select load balancer. So what I now need to do is I need to figure out a Helm command to update that release, the Athens release. And I need to figure out how to set the service.type configuration parameter to load balancer. And then I can do my update. I can set the new configuration parameter. I can cross my fingers, and hopefully I can see Athens running on a public IP. So Helm has an upgrade command, and it's got a ton of help text. So it upgrades a release to a specified version of a chart and or updates chart values. So that's exactly what I want. I don't really need to upgrade to a new version of the chart. I'm fine on that one. If I wanted to go to 0.5.0, then I would do that, but I'm not going to do that right now. But I do want to update chart values. So to update chart values, you use -- set. So I want to do something like this. I'm going to just open a little scratch window here. Helm upgrade, go mods, Athens proxy. And then I want to do set. And if I remember correctly, it was service.type equals load balancer. Okay. So I don't think that's going to work. So let's go back and look at some more documentation. I think they have examples here. Yes. So they do Helm upgrade, and then they do their -- set, and then they do the release name, That was the Athens. Remember when I did -n equals Athens? And then they do the chart. So the chart in this example is on disk, but ours is a gomod / Athens - proxy. So I'm going to copy this in. I'm going to try to make it match. So I do my Helm upgrade, and then I do my -- set. And then I have the name of my deployment, and then I have the chart. So remember, this is the chart that we got from that S3 like URL. And so we're not doing anything on disk, which is a little nicer because I don't have to find where the chart is on disk anymore. So I think this will work. So just to make sure, I'm going to do a Helm list again. And here's the release name. It's at revision number 1. So once I run this command, I should have the release with 2 revisions. The second revision should update the service type. So let me copy this in, and let's see if it works. Okay, so we've got the deployment. The deployment, like I mentioned, creates pods, which are here. I don't remember what this is all about. I don't remember what the service account is all about. But the one thing that I like is that now it says load balancer. And its external IP is now pending, not none. So in theory, after a couple minutes, since this Kubernetes cluster is on Azure, in a couple minutes after Azure provisions a new load balancer and gives me a new public IP, eventually this should show up as a real public IP. So before I ran that Helm status Athens command, I'm going to run that again and again and again until I see a public IP up there. There it is. Okay, so somebody go to this IP. I will put it in the Zoom chat. Someone go there and see if you can see just the home page to say welcome to Athens or something along those lines. Tell me what you find. This is the interactive part. If nobody does this, we're going to sit here in silence. Cool. All right. So I don't know your full name. So B. Schaefer, can you try doing a, can you try setting your Go proxy to that IP address and then doing like a go get something like this? Maybe that. So that's setting the Go proxy to that IP address, but make sure you put HTTP and then really just do a go get and put any package name that you want there. Anything that really exists. Tell me if it works. And in the meantime, Kubernetes will let me get logs. So I can get logs for a pod in Kubernetes. So I'm going to get logs for this pod because this is the actual Athens service that's running. So Kubernetes has this command line tool called kubectl. And then I can do logs -f. This is just like tail -f. And I put the pod name, that's the running container. And then I have to also put a namespace. So this -n is different from the Helm -n. This -n is the Kubernetes namespace. So logs, well, there we go. I don't think Athens was configured to output development logs, so I don't think anything will show up here. But let's see. Cool. So B. Schaefer, you got it. That's great. B. Schaefer, if you want to share your name, I can call you by your real name too, but it's up to you. And yes, Banner, thank you. So, oh, you said that above too, sorry. So yeah, Banner, you're right. Jaeger is for tracing, for distributed tracing. So this is a topic that I am not as familiar with as I should be. but the basic thing is that Athens talks to a lot of external services. Like it can talk to S3. You can configure it to talk to MongoDB or Google Cloud Storage or Azure Blob Storage or a bunch of other places. And Athens also has subsystems that can talk to like um, distributed concurrency systems. And there's a lot of things that Athens can be configured to talk to. Um, and Jaeger and in general distributed tracing allows you to visualize all of those calls out to other services in a similar way as you would see a stack trace in like a Go application if you were to panic. So Jaeger allows you to visualize Athens talking out to other systems, sort of like it's doing function calls. And then you can see a stack of starting with Athens at the top of the stack, going down to like S3 and to other whatever other systems that Athens uses. So it's been a long time since I actually fired up the Jaeger thing. The Jaeger Jaeger has a dashboard, but we have 6 minutes. So what the heck? Let's try to. Yes, it would have a UI service. I haven't done this in like I want to say 6 months. So let's just do it and see what happens. Jaeger has a pod here. I think someone just said that in chat, but it also has a service here that is sitting in front of the pod. And since Jaeger has a UI, in theory, we should be able to set the service type to a load balancer, just like we did up here, and then go to that IP address and hopefully see a dashboard. Who knows? Let's see what happens. So I'm going to go back, do the same exact thing with the Helm update, except this time I need to figure out what parameter to set to make this thing external. So back to values.yaml here. I think there's a section for Jaeger. Yep, Jaeger.type equals, it would have to now equal load balancer. So let's go to my little scratch pad. And instead of service.type, I want to do Jaeger.type. And I'm going to close this thingy, do a control C there. I'm going to do my Helm list again. And it says there are 2 revisions in Athens. So now I should do my update, and it should give me a 3rd revision, I hope. So this is very rusty skills from me in the next 4 minutes. Let's hope we can get something going. Upgrade failed, invalid, blah, blah, blah. Invalid value, service port. Wow, I have no idea what's going on here. Anybody have any ideas? Jaeger.service.type, okay. Let's check it out. I'll clear the screen again. Please work. May not be used when type is cluster IP. Well, we got closer. We have less terrible error output, so in theory, we got closer. Let's see. Let's see what's in values.yaml. Jaeger.type. Oops. Oh, maybe I should do that. Good idea. Port forward from the pod to my local machine. So, oops. Yeah. All right. So you do port forward, and then I have to specify the pod, and I imagine the namespace. Is that right, Banner? Okay. So I'm going to go back and find that Jaeger pod. Can I do it with the service, or do I have to do it with the pod? Okay. I'm going to do it with the pod. Let me find it. Okay. So I'll copy this, kubectl port forward -n Athens for the Athens namespace, and that type name and list of ports. Wow, I haven't done this in a long time. What port is Jaeger running on? I think I might need to do the Jaeger logs to find out what port it's running on. Oh boy. I do not remember. Maybe it's this. I think it might be that. Oh, okay. Thank you. Oh, and Chris, you did it. Okay. 16,686. We're Kubernetesing together, everyone. 16,686. I think there's something else I missed, but let's just make a little bit of progress. Okay. I didn't miss anything else. So we should be able to go there. And that doesn't work. I don't have iTerm on this machine, so I can't click it. That sucks. Okay, so here's the UI. There's nothing to trace though, because Athens is configured with local disk storage only. So there's no services that Athens has talked out to. You can see here. If there were though, you would see operations, at least one operation per service. That's kind of like a function call. And then there's kind of this nice timeline, and the timeline has basically different lines going, which represent different services, and then it has arrows. So this thing has been really useful. I actually did have it set up in the last Kubernetes deployment I did for Athens because it was talking to MongoDB. But alas, I no longer do. So that's about it for today. We've done a bunch, but we haven't even scratched the surface really for Athens on Kubernetes. So we'll see next week. If folks want to dive deeper into this, we will. And if not, then we'll find something else to do. So that's our time for today. And thank you to everyone who helped me with Kubernetes stuff. Especially thank you to everyone who came as well. Join us next week. It's going to be a great time, just like every week. At least I love these, so thank you for coming. At least to make me happy. So yeah.
Cheers for your time, Aaron.
Yeah. Well, same time next week. Thank you. See you, everybody.
Bye.